Right, guys, so we are going to talk about the transactions in the Bitcoin network. Um, Now, the transactions are digital signatures, and they go from one owner to another. So let's actually just go over everything here in just a second. So we define an electronic coin as a chain of digital signatures. So essentially, in real life, we just give each other cash, right? So if I want to give cash to another person, then it's really easy. You just use cash, right? You just go to the bank and you just take cash out because they are the ones that print those bills. So that's what it is. So here, Bitcoin represents the same transaction where I just give cash to another person, except that it's not physical cash, but it's a digital cash. So how would you do that? It's not just as simple as um, me going to the Bitcoin website, logging in, and sending cash to another person. If it was the case, Bitcoin will be shut down. Bitcoin, because it's not being controlled by the bank. That's why it will be shut down. Bitcoin.com, the website, if that would ever exist, then that would be the one that would help you transfer money to another person. That will be shut down because the bank wants the power to be able to be the intermediary. So here they want to explain to you that this whole Bitcoin uh, protocol consists of digital signatures as a proof. So let's continue reading. Each owner transfers the coin to the next by digitally signing a hash of the previous transaction and the public key of the next owner and adding these to the end of the coin. A payee can verify the signatures to verify the chain of ownership. So just like the image, as you can see, starting from the left to the right, um, that first block is a transaction, right? So all of this is a transaction, right? So this whole big rectangle is a transaction, and you see owner one's public key uh, is used to construct the hash, and then the that will be passed to the next person, um, and using their signature, their public uh, signature, and to get the money they use their private signature to actually pass it on to the next person. They use their private key. So essentially, every person, instead of just carrying cash, they have a set of signatures. One that is public, as you can see, owner one, public key, that's the public key. And then another key that I keep secret if I want to pass the money to you, like a $10 bill. If I want to give it to you, before I give it to you, I have to make sure that I have the public key and a private key. Um, so the public key will be super important, but the private key is even more important. So everybody has that set of keys, the private and public, and using the public key to create a hash, that's a transaction, and using my public key, I can create a hash. And the hash will be mixed with my public key and the next person I'm trying to give the money to's public key as well. That's what creates a public a hash, which is a transaction. And next, once you receive the cash in your hand, um, you can keep it. You don't need to do anything. However, if you want to give it to somebody else, you'll use your private key to sign the new transaction to pass it on to the next person. See, you use it to pass it on to the next person. And the public key is used to verify uh, the previous uh, owner's signature. Um, I know it sounds complex. Let's read over. So that's basically what makes a chain. Whatever happened here as far as the exchange of keys, it's the same thing that happens when the money moves from one hand to another, right? So basically, an exchange of signatures. That's pretty much all it pretty much is. It's an exchange of signatures when the money passes from one hand to another. So that's what this diagram is. So the problem, of course, is the payee can't verify that one of the owners did not double spend the coin. So a common solution is to introduce a trusted central authority, a bank, or mint that checks every transaction for double spending. That's what's happening right now, right? Every time you make a transaction, except for cash, we're using your credit card or debit card, the bank has to verify if you didn't already spend that money that you're about to give to somebody else. So the bank has that job as of today, and everybody seems to be happy with it because it seems to be working. Nobody has a problem until they have a problem. And so that's the common solution, to add a trusted central authority, which is a bank. After each transaction, the coin must be returned to the mint to issue a new coin. And only coins issued directly from the mint are trusted not to be double spent. So the problem with this solution is that the fate of the entire money system depends on the company running the mint, with every transaction having to go through them just like a bank. Right, so again, that's what I just explained. So if you have a bank in the middle, you have to trust the bank, to validate every transaction properly, like, with your eyes closed. So we need a way for the payee, so owner one, to know that the previous owners did not sign any earlier transactions. Correct, so that there's no double spend. So for our purposes, the earliest transaction is the one that counts. So we don't care about later attempts to double spend. The only way to confirm the absence of a transaction is to be aware of all transactions. In the mint-based model, the mint was aware of all transactions and decided which arrived first. Right. To accomplish this without the trusted party, transactions must be publicly announced, and we need a system for participants to agree on a single history of the order in which they were received. The payee needs proof that at the time of each transaction, the majority of nodes agreed it was the first received. So essentially, right now, the bank has to do this job, right? Of confirming your transaction. Let's say you go to Starbucks, right? You go to Starbucks, you want to pay for your coffee. So when you swipe your card, it sends an authorization to the bank. Like, the bank has to say, hey, okay, does this person have enough money to cover for this payment? And the bank has to approve it. So it's not an automatic process. A lot of people think that it's really like automatic, like, nobody's behind a computer, or this it's not as simple as most people think for a bank to approve every transactions. I know in different countries they don't validate transactions like instantly. They don't. They may validate it, but by the time it show up on your bank account, like, you know what I mean, like, it's not as quick as a lot of people think. I'm not a financial person, but essentially, there was something called a batching, I believe, that every company or merchant has to do at the end of, I don't know, the week or something. It's an exchange of information like that with the bank and the merchants that eventually, if everything clears, if you didn't contact the bank in the meantime after your purchase at the Starbucks to say, hey, I didn't make this purchase, then they get their money, like the merchant get their money. But if you contacted them, then the bank, the mediator of all times, have to cancel everything, tell the merchant, hey, you're not going to get the money because this customer said that he didn't, he didn't make this purchase. So that's essentially what it is here, and they kind of discuss this problem. In the next video, we can probably talk about the timestamp server. Actually, we can discuss this right now. The solution we propose begins with a timestamp server, so that continues the order of transactions that we kind of just read earlier. We don't trust the bank in this system, so essentially, how do we know what time you made this transaction, right? The only way we know is that we all agree, like all the validators of the transactions, they have to agree on what arrived first. And in order to do that, so the solution we propose begins with a timestamp server. Timestamp server works by taking a hash of a block of items to be timestamped and widely publishing the hash, such as in a newspaper or Usenet post. That sounds very old, but I'm not sure. The timestamp proves that the data must have existed at the time, obviously in order to get into the hash. Each timestamp includes the previous timestamp in its hash, forming a chain with each additional timestamp reinforcing the ones before it. You have an image right here that kind of explains what it means. That's basically the blockchain, right? So it's a chain of blocks. So every block that is validated, so a block is a let's just say it's a block of transactions, right? Every transaction is validated, and once it's validated and approved by the community, then it gets entered into a block. As you can see right here, and the block contains every item is right here. So it's a transaction, and basically each block has a hash, and that hash is the timestamp. I believe we can talk about the hash a little later, but essentially it's a formula. It's a mathematic formula that calculates based on an algorithm what like basically it encrypts this whole block, and that's how we're able to determine which one came first. But in the next video, we probably will talk more about the section 4 proof of work. Is probably the most interesting section, and we'll go over that very soon. All right, thank you.